Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT One, the consultancy that helps companies create value from data to accelerate growth. And our guest today is Jack Kang, Senior Vice President of Business Development and Customer Experience at SiFive. SiFive brings RISC V software and silicon experts together to innovate with a modern, software-driven approach to semiconductors. In this talk, we discuss the importance of the RISC V open standard for semiconductors to provide design freedom, vendor choice, and long-term tech stack flexibility. We also explored how companies from automotive OEMs to wearable device manufacturers are differentiating their products with custom design on open standards. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, you can email us at team@iot1.com. Finally, if you have an IoT research, strategy, or innovation initiative that you'd like to discuss, please email me directly at erik.walenza@iot1.com. Thank you. Jack, thanks for joining me on the podcast today.
Yeah, thanks for having me.
Yeah, I'm looking forward to this conversation. Actually, the topic came up. I was hosting a panel last night on this topic of innovating in Asia. And we had people from Bosch, from Intel, from JLL, the property developer, on the panel. And then RISC V came up as a topic because obviously China, semiconductors is an important issue right now. And then you just corrected me during our conversation here that despite the fact that it reads RISC V as the international standard, it is actually RISC V. So maybe that's a good place to start before we jump into your company, SiFive, to discuss a little bit what is the international standard and what is the international standard body behind this technology.
Yeah, I think it's a great question. I think it might help if I give you a little bit of history of how RISC V came to be, and kind of the fact that it came up in a panel yesterday with that diverse audience is pretty incredible in terms of the global phenomenon that is RISC V, because it started off in 2010 as an academic project. So a couple of grad students at UC Berkeley, along with a professor, needed an instruction set that they could modify. And an instruction set, which we get into more details later, is the interface between hardware and software. And for research purposes, they needed a instruction set architecture that they can play with and change and do different things just for their own PhD purposes. And really, the only options realistically that exist in the world are either x86 or ARM. So this is pretty interesting because if you look at all of the compute interfaces, think Ethernet, think Wi-Fi, think PCI Express, think any interface, anything that's a standard. The ISA is the only one where all that exists are proprietary standards. So x86 is something that's very complicated. There's only 2 companies in the world that pretty much build it, Intel and AMD. And if you want to use that, you have to buy a chip from them. The other is ARM, which is used across the world in most chips in the world today. Many different vendors all deploy ARM-based solutions, but actually all of the cores come from one company called ARM, and that's also proprietary. So the problem that the researchers faced at UC Berkeley back in 2010 was they couldn't modify these ISAs without permission from either Intel, AMD, or ARM, and it was just kind of not possible. So they decided to create their own, originally as a 3-month project, as a research project, to have something that can be used for research purposes. And the reason it's called RISC V is actually at UC Berkeley. That's where they invented the original RISC style computing. So back in the 80s, when they were ARM, the CISC versus RISC debates, the RISC style architecture came out of UC Berkeley, and this was actually the 5th generation research project that came out of Berkeley. So that's why it's called RISC V, because it's the 5th generation of it. They just used the Roman numeral V to announce 5, both because they were students, but also because one of the key areas of future innovation was vector style computing. So it's kind of an inside joke that V would stand for vectors, but really it was driven by the fifth generation of RISC-V, RISC style computing, which is why it's called RISC-V.
In RISC, what does RISC, the acronym, stand for?
Yeah, so RISC, RISC, that stands for Reduced Instruction Set Computing, which is kind of a style of compute as compared to CISC, which is CISC, which is Complex Instruction Set Computing. So traditionally, an x86 would be considered a CISC style machine, whereas ARM would be considered a RISC style machine. But these are more semantics these days because the CISC type x86 does a lot of RISC things under the hood. The RISC like ARM actually has a lot of complex instructions. So it's really more semantics more than anything. At the end of the day, it's about what is your performance, power performance area. What does your ecosystem look like that people really care about, as opposed to, is it a pure CISC or a pure RISC instruction set? But, most people learn that in their computer architecture classes or kind of their computer science classes. So it's an easy delineation for people to make. So RISC-V obviously follows the RISC lineage. So part of it is the ease of implementation in that it is a reduced instruction set, so it's less complex than some of the other instruction sets out there. And as it turns out, that the original principles apply. You can actually make much more efficient implementations with a clean instruction set that's reduced instruction actually is more capable than adding lots of things. It tends to become baggage after a while. After 30 years of an instruction set, adding things, you end up with baggage that can be detrimental for modern workloads. But we can get to that because now I think I'm getting off your original question.
Yeah, well, I know that SiFive focuses more on IoT applications. Is that generally for the RISC-V standard? Is it generally more well suited to IoT applications as opposed to, let's say, for a desktop computer or a server?
No, so actually that's a misconception. And actually, RISC-V is well suited for all sorts of computing. And if you, we say RISC-V is inevitable, and we think RISC-V will be in every single device, from embedded small IoTs to consumer devices to phones to data centers to AI, aerospace to autonomous driving, automotive. It's suitable for all of these cases. Just because it's RISC-V, you can have different implementations of RISC-V. Very high performance implementations, very area efficient, very small, very tiny power. You can have all these different implementations. And one of the beauties of RISC-V is it's going to share all the common software and ecosystem, which is one of the things that's so appealing about it. The reason why most folks know about RISC-V in the context of maybe IoT and edge devices is that's where it got its start. Because as RISC-V, I mentioned earlier, was a research project in 2010. And SiFive, the company, wasn't founded till 2015 when we started to then commercialize RISC-V devices. And RISC-V is the standard upon which you have to be compliant to, but then you have to have different implementations. So it turns out that a lot of the early implementations of RISC-V tended to be for the smaller IoT type devices, less complexity type devices, because it's simply faster to get there. Over the last few years, you've seen this explosion in RISC-V, not just from SiFive, but from other companies, of it going into these other applications because it is very well suited. It does give better performance, power, area compared to competitive solutions in these high performance spaces as well, such as like autonomous driving, data center servers. So really, RISC-V will go everywhere, and it's something that I think maybe 10 years ago when Krista, one of the inventors of RISC-V, said that RISC-V is going to be in every computing device in the world, people kind of like, oh, that's nice, that's very ambitious. I would say now people are like, oh yeah, that's going to happen. It's just a matter of when and how long will it take and which markets along the way, right? It doesn't mean that everything else goes away, but it's like all the new things are moving there, which I guess I'll go back to your original question here. Why is there a RISC-V International? Why is there a standards body? Because what's very important about an instruction set is that everybody knows what it is, because it's really the contract. You can think of it as the contract between the hardware and the software. So when you write the software and you have the compilers and everything. Like, what does that compile down to that the hardware knows how to execute? So this standard has to be open and maintained. That's like the big differentiation from RISC-V versus ARM or x86, is that the RISC-V standard is an open standard, which means it's accessible by anybody. Anybody can use it. You can use the standard and you can develop your own CPU. You can develop your own CPU and keep it a secret. You can develop your own CPU and tell everybody you're doing this, but not give it to anybody. You can develop it and you can license it. So that's what SiFive does. We license our CPU designs for other companies. But because it's an open standard, everybody gets to compete and everybody gets to participate in this ecosystem, which is very different than the proprietary ones that I mentioned earlier, which are controlled by one or two companies. So because it's an open standard, you need effectively a standards body which manages the standards, right? As things change, new enhancements, how do we decide what goes in, what doesn't? Well, that's the job of RISC-V International. So RISC-V International is a nonprofit made up of member companies. Pretty much all the technology, semiconductor companies you can think of are members of RISC-V International. And RISC-V International, their job is to manage the specification and keep it open for anybody to access. So that's why there's that body there. They don't actually produce anything. They don't create any cores. They really just maintain a spec, plus some general marketing and goodwill. But really, their real output is managing the specification.
Okay, and I guess the advantage in the market of a standard over a proprietary, an open source over a proprietary protocol is that you have a group of people that are a group of companies contributing to move forward this protocol, as opposed to a small set of companies that own the protocol. But you mentioned also that, of course, companies, when they develop something, they can keep it a secret. They don't necessarily have to share it. Who tend to be the big contributors here? Is it companies like SiFive? Is Intel involved in this, and are they pushing it forward despite having their own protocol? Or is it more universities and academic institutions that are kind of putting forward the research that enhance the standard over time?
Yeah, so couple of points in your question there. So I think the one thing that you mentioned was the whole open source versus the open standard. So I think this is a very important distinction that is easy to get confused. So the RISC-V instruction set standard, the specification of the instructions and how it interacts, that's an open standard. That means it's accessible. It's a standard. You can use it to do whatever you want with, which is different than open source. Because the standard is open, I mentioned earlier, it allows for different implementations. You can have your secret private one, you can do it, you can license it, you can do whatever. It also means you can implement a core and put it in open source. So this is what happened with RISC-V. There are multiple open source implementations of RISC-V, including the original design that was done at Berkeley is available in open source, which means you can just download it and access it. That does not mean all of RISC-V is open source. That doesn't mean all implementations are open source. It just means that you can have open source implementations. But this is still appealing because there's just places where you want open source implementations. Maybe you're doing research. Maybe you want to share what you're doing. Certain projects will do it. And then there's place for commercial implementations. If you're spending hundreds of millions of dollars to build a chip, you probably want a company to stand behind your CPU so that there's choice, right? So an open standard gives people choice. So it's not correct to say it's an open source. It's an open standard. And what we've seen in our industry is all the other interfaces in our industry are all open standards. Like think Ethernet, for example. Anybody can implement Ethernet, but there's companies that specialize and do very well, like Cisco, for example, right? They implement Ethernet chips. They do it better than everybody else. So that's kind of the big difference between open standard and open source. But then within the standard itself, you kind of ask who are the contributors to it. And it's actually both. I mean, you get the power of all the different companies looking into this. So RISC-V International has a technical standards committee. It's made up of member companies that, like SiFive are commercial. They got their commercial interest. They got their commercial deployments. So they have to make sure that what is in the standard makes sense from a deployment standpoint. But you also have the community, open source developers, maintainers, their input gets to come in because, they they are writing software for these things, and they have very good input on what makes sense and what makes things more efficient. So you do get the benefit of everybody contributing together. So your innovation happens much faster versus it being just controlled by any one single company. And then because it's an open standard, if there's ever something that is not in there that you need, you can just go ahead and add it yourself and put it in. Now, once you do that, you have the option of coming back to the standards body and saying, hey, we should add this thing in there. It's really useful, whatever. Or you can keep it for yourself. The key point here is you're never stuck. You're never held captive by any individual company. So like, ARM, for example, if you're a customer and you go to ARM, hey, please do this, please add this to your thing. And ARM says no. Well, you really don't have much of a choice if you want to keep using ARM, like, because they're the only ones who can provide it for you. Whereas with RISC V, you have the freedom to do it yourself. You can have SiFive do it. You can have other people who compete with SiFive do it for you. So the competitive environment is completely different in that ecosystem versus the others, which is why you're going to have a proliferation of different design points. You can have way more design points. You can cover all these different markets that you talked about earlier with different implementations, because one company doesn't have to do it all.
Gotcha. Okay, great. Thanks. So maybe we can turn now then to SiFive. If I think about SiFive just very high level in terms of the business, would it be comparable to ARM but built on an open standard? Is that a good way to think about the business?
Yeah, that's probably the simplest way to think about the business, and it's mostly accurate. Of course, there are some differences, but yeah. So fundamentally, SiFive, we were founded by the inventors of RISC V, the same folks at Berkeley that I mentioned, and we focus on developing RISC V technology. So we have a very broad portfolio of licensable RISC V cores, RISC V IP, that we license to companies who build chips. So these are traditional chip companies that build chips, but these days also a lot of OEMs. It's getting more fashionable to build your own chip, right? A lot of companies are building their own chips, so that's also why the semiconductor industry is growing so fast, because the number of people who build chips is not just limited to a chip company that wants to sell their final chip product to an OEM, but a lot of the OEMs themselves, a lot of the data center guys, a lot of the cloud guys, everybody's also building their own chip. So anybody who builds a chip would be a customer of SiFive. And I mentioned earlier that it's all built on the RISC V standard, and the standard is a standard, but you can have different implementations that go into many different types of products. So we have 4 families of cores. We have our essential cores, which go in a lot of the embedded and IoT things that you talked about earlier. We have a performance line. This is like very high performance cores. This will go into mobile, consumer, data center, edge server type devices, very high performance CPU cores. We have an intelligence product line, which combines RISC V with very wide vectors, the vectors that I mentioned earlier. And this is very well suited for all the new classes of generative AI and transformers and AI calculations and connecting accelerators. It's about number crunching and programmable number crunching in that space. So that's our intelligence product line. And then we have a 4th one called automotive, which adds, takes the elements of the other 3, but adds the functional safety, ASIL qualifications. So all the next generation autonomous driving, central compute, IVI type automotive functionality is also well covered. So it's quite wide in that sense. And that's actually one of the strengths of SiFive. One of the strengths of RISC V is that the wider it goes, the more software is written, the more the ecosystem is there, and the more cross-sharing there is. So it's a very momentum-driven ecosystem that it keeps growing and growing. And because it can touch so many different market segments, as that grows, you just get more software, and then it kind of moves around, and it just makes each market stronger as that happens.
So let's use an example. Let's say I'm an automotive OEM, and I want a chip for my new e-vehicle that has a lot of computing requirements. What would the more typical case today be that I'm buying your or I'm licensing your SiFive automotive? What would you call this? It would be an automotive? I mean, it's IP, but would you call this like a
like IP core or CPU
design
core.
set or CPU core? Okay, and then I would be using that kind of off the shelf IP, sending that to a fab and having them manufacture chips for me? Or would I typically be taking that in-house and then spending 6 months, a year to kind of maybe work with you, or at least have my internal team customize that for my set? So is that customization quite common, or is that a bit of the, possible, but less, more for special circumstances today?
Yeah, it's kind of in between that. So if in your example, there's two ways really the automotive companies can work. So some of the new ones, especially with kind of the electrification, what's happening with EV, it's kind of an opportunity for a lot of new entrants and for them to rethink how kind of their electronics all work. So you see a lot of automotive companies looking to build their own chips to differentiate their products, right? I think Tesla is a very famous example. They started building their own chips. A lot of people kind of follow in that way, especially in China. I know you live in China. You see probably more EV cars than we do here in the US. I guarantee you, there's the amount of EV cars in China is like incredible. But those are all brand new. So all those companies are looking at how do we build new things. So either they're building themselves, option A, or they are working with their existing chip supplier and say, hey, chip supplier, please do this. They're specifying it for the chip company. Say, hey, we need these capabilities, we need these features, we need that type of stuff. Or they do it themselves. In either case, the way they would work with somebody like SiFive is obviously they need, the CPU IP from us. You're looking at new capabilities, new functionality. They might work with us to make sure that it meets the next generation products. There might be certain enhancements that we might do, different configurations that might make sense. But that's still just the CPU core. It's a large part of the chip, and there's a lot of work that can be co-done together. But then they need to still put that into their SoC. So there's other components in the SoC, peripherals and GPUs, maybe dedicated accelerators that either the chip company or the automotive company would need to work on themselves or with other partners. Now, you want those things to work well with your main CPUs and your subsystems and your safety islands and all of that stuff. So it's a very collaborative process during that entire, chip building period, which, that could be 12 to 18 months to design something like that. Fundamentally, the baseline CPU IP core we provide, we work with the customers closely in terms of configurations, customizations, extensions, things they want to do in that front, both for the core itself or working with, within their SoC to make it match up very well with their accelerators and other stuff. Because it's about, differentiating the product. Like RISC-V lets you differentiate your product in ways that you couldn't, right? Because if the existing market today, you get the product from ARM, your product is the same as everybody else's product, right? That's one of the issues that they're facing because it's all one and the same, come from one place. And one of the other driving factors, because this is a really good example, so sorry for the long answer. One of the other driving factors is the car industry is going through a change, right? The cars are getting electrified. The autonomous driving capabilities are all expanding significantly. So they all have to write brand new software. So when they write brand new software, they have a fundamental decision they have to make. Is like, what ecosystem do I want to invest all of my software development, all of my software resources on? And really, there's x86, ARM, or RISC-V. So we see a lot of customers saying, hey, I had to rewrite this anyway. Why would I not use RISC-V, where I'm going to have lots of choices and options to innovate in different suppliers in doing so, versus one of the proprietary older ones where then I'm going to be single vendor limited. So if I'm investing all my resources in a single vendor, that doesn't seem that prudent, especially when there's choice, right? So that's really the big, if you zoom out, why is RISC-V taking off? Why is everybody looking at it? Besides the performance is good and power is good and features are good. It's that choice of freedom and that being in that ecosystem where there's going to be lots of options is really what's driving it first order. Then they get to like, hey, the power is good, performance is good. That's kind of validating that initial decision.
Yeah, you see this in a lot of areas of the tech stack or different tech stacks today, right? So in terms of PLCs and so forth, also you have companies starting to really push for open standards, or at least more integration between solutions, so that they're not locked into one vendor. So this really seems to be a bit of a zeitgeist in the industry right now, or in the broader economy, really, right? Because it's really cross sector.
Right. Yeah, I mean, because when you're locked in a single vendor, not only are there negative commercial implications, but it's really bad for your innovation capability, right? Because then you're dependent on what that one vendor could do, and highly competitive environments, which semiconductors and automotive is fast growing. Like you can't be the one that's stuck on that if your competitors are moving.
And then you have this software portfolio as well. I mean, if we think about how your business works, is software a profit center, or is it that you license the technology and then you say, okay, and then we give you access to our software so that you can customize it to meet your needs? How does that work on the business level?
Yeah, software is basically enablement, and a lot of the software that we do is actually in open source. So this is one of the very nice things. Like if we had to build the entire RISC-V software ecosystem by ourselves, SiFive as a company, one, it would take forever, and two, there's no way we could do everything that's going on. So this is one of the really, really nice things about RISC-V is you have this whole community developing software for all these different markets and these different segments. So where we view our role when it comes to software is, we are key maintainers for a lot of key technologies. We do a lot of contributions in LLVM on the compiler side, certain libraries, like things that might be perceived as hard, or things that people aren't going to do, or things that are tied to the hardware. We want to enable it so people can use it. But the key on the software side is not that we want to do everything ourselves. We want to be the enablement of software so that more software can be written, and things that are very important or maybe very performant dependent with some of our microarchitectures. Then we will go and we'll do that ourselves and contribute that back as much as we can, so people can then leverage and build on top of that. Software is the big enablement. It's the big ecosystem driver that's going to help RISC-V grow as a whole. So we do have a sizable software team. A lot of the software development that happens in the RISC-V community happens on SiFive cores and SiFive silicon, because throughout our history, because we have been first with new products, with the new specifications, with the new standards, because we kind of lead. We also put out developer boards and things so that people can write software against them that are compliant to the standard, so that there's actual silicon for people to write software against, right? Because developing silicon is a big investment of cost, right? So not everybody can do that. We're lucky enough to be in a commercial position where we can do so. So we kind of put that out again to enable not just our software development team, but the broader software ecosystem to contribute, because this is really where the community aspect of RISC-V is really sets it apart and gives it kind of a very sustainable differentiator.
Yeah, absolutely. Certainly the strength of open. You also have this SiFive vectors solution, and I'm curious how that compares to the SiFive intelligence, because they both seem oriented around enabling AI, ML, computer vision applications. But then SiFive RISC-V vector is a kind of a unique offering here. What is the solution around this?
Yeah, no, that's a great question, and thanks for bringing that up. We should probably clarify our marketing a little bit. So SiFive vectors. So vectors is really a technology. So vector style computing is not new. It was actually invented by Cray back in supercomputers, but it's kind of come back in vogue with a lot of the workloads that exist today. So even ARM or Intel, they all have adopted various types of vector style computing. So RISC-V vectors is kind of an enhancement of compute. You can have different vector lengths, different types of implementations of that. It's very well suited for a lot of data crunching. So if you're doing sensor data or you're collecting that, but then it also lends itself very well to machine learning algorithms, AI, transformers, things of that nature. So those are where it's starting to see adoption. So vectors is a technology. And then we have different implementations depending on the type of core that we have that have, 256-bit wide vectors, 512-bit wide vectors, and other things. The intelligence product line that you mentioned is our product line that has the wide vectors built in. So the intelligence product line, so people will license our intelligence products, would generally be used in, some of those applications, maybe data center training, AI offloads at the edge. If you want to do AI on the system, we have some smart cameras, for example, that use those products and just do the processing locally. So that's where you would use the intelligence products. They just leverage the vector technology. So hopefully that cleared that up a little.
Yeah, That's clear. Okay, thanks. Maybe we can touch then a little bit more on the markets and the use cases. So automotive, obviously a critical use case because of the change that's happening in the industry and the size of the industry, and therefore you have a unique product for automotive. Beyond automotive, I mean, you have your performance line, you have your intelligence line, and your essential line. But what are the other industries that you're particularly excited about at SiFive? Potential for scaling up rapidly for adoption of, maybe especially if we look at some of the more emerging ones, the ones that might be using ML on the edge and so forth.
Right. Yeah, no, absolutely. Yeah. So I think automotive, we already covered. That's definitely one that's very exciting because of the change that's happening in that ecosystem and the growth and the number of companies that's participating in that space. That's definitely one of them. The other one, of course, revolves around AI and what people are doing here. This is rapidly changing. So one of the things that I think we've seen over the last few years is AI has changed so fast that if you don't have a programmable solution, it's very difficult. It's relatively straightforward to build hardware solutions that are hardwired, that are really good at one particular function. But the industry is moving so fast, the types of algorithms and what you need to run is changing so quickly that none of those have been really truly successful, because by the time you're out in the market, everything's like already moved. So having a programmable solution, which is what our vector technology enables, what intelligence product line presents, is actually very attractive for people to then connect their accelerators to that programmable engine. And then by doing so, they get kind of the benefit of their accelerators, but there's all this, they got this programmability that lets them adapt to new things like transformers, which is relatively new. I think we're very excited about this. We've seen quite a bit of adoption on this front, both in what I would call the edge AI case. So like the smart camera where you're doing all the processing on the edge, with vector machine, but also in the data center. So Google announced a while ago that they were using our intelligence products along with the TPU in the data center. So they connected their TPU accelerator to the vector core, and then it made it much easier for them to program the system, to run pre-processing, post-processing, offload certain things from their hardware engine into the intelligence core, and it made for a very nice match together. And then that's in the data center, right? It's not the data center server or quote main compute or whatever, but it's handling a very important offload and acceleration tasks. So those are areas on the AI side that I'm quite excited. And, I think everybody's excited about AI because it's just changing so quickly and there's so much opportunity there. But I think that's a technology that's very well suited. Again, if you're writing new software, you get to choose what ecosystem you want to write it on. So in those cases, to me, it's a pretty easy choice. Of course, you choose the open ecosystem. Now, if we talk about a market where there's lots of existing software, well, those are harder to change because you have all this existing software and ecosystem, and you're like, well, why do I want to switch over? I had to redo all the software work. It's a lot. It's all this other things. But we see that happening for RISC-V also. So, for example, one of the other markets they're very excited about is the mobile consumer market. And if you haven't been following closely, Google's made a few announcements in the last few months here about Android support coming for RISC-V. And Android, RISC-V will be a first-class citizen for Android. A couple of weeks ago at the RISC-V show in Barcelona, Google was on stage talking about how the RISC-V NDK will be available by the end of this year, 2023. The CTS are being worked on. So you can tell Google's very serious about Android work for RISC-V. I can't speak for them because that's not my place. But so I can only point to the public information and ask you and listeners to kind of read between tea leaves. But Android is clearly coming for RISC-V, and that's opens up so many opportunities for the RISC-V products to then go into. So that's another area that I'm quite excited for, because if you ask me when we started SiFive, and we started the company in 2015, and then I was here and we had to literally explain to the world, every person we met, what RISC-V was and why it mattered. If you'd asked me then, like if I thought Android would come to RISC-V, I would say maybe, but that might be the last thing to come after everything else is gone. But it's happened much sooner than that, which just goes to show, I think, the global phenomenon that RISC-V has tapped into. It was bigger than even us, the biggest proponents there could be. We all started the company for this, could have predicted back then.
What about LLMs? Because you have this situation right now where NVIDIA pretty much dominates the market, but you really have supply chain constraints that are limiting people's ability to actually, build on this new technology. Do you see risk? I mean, what would be a timeline for RISC-V becoming a viable competitor for NVIDIA in terms of enabling companies to build LLMs?
Yeah, I think getting into prediction business is dangerous. I would say that I think what NVIDIA has done really well, and I was at NVIDIA before I joined SiFive. To me, the strengths that they have is they have a programmable system. They have CUDA. People can program to their devices, and they have the biggest, best programmable data thing. Really, that's why people use it. As things continue to evolve and new models come up, people are going to look for new, additional ways, different ways, more efficient ways. I think the very nice part about this is it's not a done thing, right? We're at the very beginning stages of what AI and what LLMs and what's going to be next can do. So I think there's going to be lots of software changes that are still happening. Where there's compute and where there's more compute, I think RISC-V has a very strong play, right? So I don't view it as like, oh, can you get there and it just replaces all of NVIDIA things. I think it's going to be, hey, as new things get developed, some things are going to run better on NVIDIA GPUs. Some things will probably run better on RISC-V vectors. Some things will run better on RISC-V vectors plus accelerators. And it's going to be kind of open competition for, combination of the hardware and software together. So this is kind of really exciting because I don't think anybody can predict it other than we know that the amount of compute that the world needs is going to massively increase. So that's why everybody loves the chip companies and what we're doing right now in the space.
Yeah, great. Let's touch quickly on China. So, I'm sitting here in Shanghai, been here for about 12 years now. So it's kind of my second home. And I know you're going to be visiting soon. I mean, China's a fascinating market, right? Because there's this enormous demand driven by e-commerce, by traditional industries, but also by this very rapid development of the EV market here. It's also now for your industry a bit more of a complicated market because of the tensions between the US and China. How does this look as a market, maybe for SiFive, but also just for RISC-V adoption more generally?
Yeah, no, I think, we certainly, from a semiconductor standpoint, nobody in the world can ignore China, right? I mean, if you look at the number of companies in China that are trying to build chips, develop products, you mentioned the EV companies, the number of EV companies developing autonomous driving solutions in China is mind-boggling. I was there a few months ago and, post-pandemic, got a refresh. And, if people who haven't been there, you're there, so you understand. It's the amount of electrical vehicles, the energy level, the enthusiasm for building is just something that you can't compare. So the number of things being designed in China is just a very high number. So that naturally presents huge opportunity in terms of design sockets and other things that require, CPUs, including RISC-V. But the other really important thing about RISC-V I mentioned earlier is it's an open standard. So this is something that is very attractive to China because they want to develop on an open standard, because then as they develop more software and they develop products, an open standard provides a kind of a choice of different options for them to do so. SiFive, we're a US company and, we're very careful and diligent in making sure we abide by, all the regulations and things like that. Where there's business, we're happy to work with customers there, but customers view RISC-V as a way for them to develop within China more products in ways that will be less constrained. There's a positive push towards RISC-V that in China that is actually larger than in other regions of the world. So actually the RISC-V events that happen, the biggest events happen in China. So the most number of attendees are actually in China. The other thing that's happened with RISC-V is RISC-V is now the standard upon which computer architecture is taught at universities all around the world. So the number of engineers who are graduating who know RISC-V is increasing, but it's also increasing the most in China because they have the most engineering and graduate students graduating each year. All this is to say that, I think RISC-V is very important for China and the China market. And actually a lot of the open source software work, some of the technology is being driven very much by companies that are local in China.
Okay. That makes complete sense, right? There's an enormous hunger here, and I really encourage anybody who's listening who hasn't made it to China since, let's say, 2018, 19, to make a trip over. You might have come over for the automotive fair. I've talked to so many German executives who came over, the first time in 3-4 years, and were just stunned by what they saw at the automotive fair, right? In terms of what's coming.
It was shocking. I was shocked too. I was like, I guess it's just anecdotally just walking on the streets of Shanghai, and you're like, all these cars are brand new and they're all electric, and you can tell because they got the green license plate, and you're like, all these are like electric and they're all brand new. And that's how my friend, it's like, and then these companies that you maybe only partially heard of, they're all here, they're all doing this stuff. They all sell their cars in the open air malls with the fancy displays. It's kind of like, for American listeners, like how Tesla does it. There's more car dealerships than Starbucks. It's like, it's crazy in that sense. It was definitely a post-pandemic, quite a shocking, in a good way, surprise, I would say.
Yeah, well, I think in Q1 of this year, they surpassed Japan as the leading automotive exporter. So we'll see if they maintain that for the remainder of the year, but that would be quite a upheaval over the past few years, because only 5 years ago, China was kind of viewed as a market for vehicles, but basically unable to produce anything competitive, right? So it's all state-owned enterprises that were having joint ventures with foreign automotive OEMs and basically just manufacturing centers, but nothing branded and nothing particularly innovative. So that's been a pretty rapid shift.
Absolutely. But I think you see the global OEMs also reacting now as they see this happening. And, I think part of this, the innovation in automotive is going to happen much faster than it has historically. The idea of introducing platforms every few years versus, every year, you're going to see it happening sooner and sooner, primarily driven by a lot of the Chinese OEMs. So I think it's good for competition around the world, definitely good for the consumer, good for semiconductor providers like ourselves, because that means there's more new designs.
Yeah, well, maybe this is a good place for me to ask you my final question, which is, you guys are really at the nexus of a lot of the technological shifts, the economic shifts that are happening in the world right now. So what are you most excited about? If you look at the SiFive product roadmap, if you look at the kind of the market forces right now, what excites you?
Yeah, I think if you look at the company when we started, there was kind of this belief that, hey, this guy's pretty cool. And it's like, well, can we convince everybody of that? And okay, we did that. And it's like, okay, well, then can we actually build the products that people care about? And we did that. And now, I think the momentum is just self-fulfilling. And it's like clear that RISC V is going to be adopted everywhere in all of these segments, all these new things that are happening. And that's like the most exciting thing. And actually what keeps me up at night is our ability to execute towards all these customer demands, because we get pulled in different directions, because I can go on all these different markets. So for us to make sure we properly service, our customers in the right markets so that they can be successful and then grow it, that's kind of the challenge. But the excitement is like, oh my goodness, I see a world where everything is RISC V, and that's pretty exciting for us.
Yeah, no, you have a very broad, you have a broad product portfolio, and pretty much any industry in the world could be your customer, right? So yeah, this is an execution.
That's right. Execution challenge. And then picking and choosing, make sure you prioritize the right ones, because as much as you'd like, you can't do everything right away. Everything maybe over time, but that's kind of the path. And that's the fun, right? And that's at least my day job is working with different customers and understanding, what they're looking at and how they want to differentiate their thing and how we can help them. That's a really fulfilling part of what we do.
Yeah, great. Well, Jack, I think you've given me a good education, so hopefully the audience feels the same. Anything that we didn't touch on that's important for folks to know, or any last thoughts?
No, I think I would just encourage anybody who's in this space to go, read more, learn more about RISC V. It will be pervasive. You can get involved. There's lots of different ways to get involved. If you're a software developer on the open source software side, if you're a hardware developer, either with companies or with open source, there's lots of different ways. If you find this exciting, interesting, that you can get involved either at an individual level or within your companies or whatever else. And it's pretty easy to find the resources if you just search, SiFive or RISC V.
Yeah, great. Yeah, so for the folks that are listening, that's RISCV.org. RISC V, and then SiFive is SiFive.com. Jack, thanks so much for taking the time today. Really appreciate it.
Yeah, thank you for having me.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.